Now let's talk about prediction. Under certain conditions, you can use the line of best fit for estimating y when you know x. The conditions are if the scatter plot looks linear, the correlation coefficient r tells us that the relationship between x and y is significant, and x and y are related in a way that is reasonable for y to be dependent upon x. For example, generally tall people weigh more than small people. The process of estimating y when you know x is called prediction. So let's take a look at an example. A study is done to examine if women wearing larger size shoes tend to be taller. So x will equal a woman's shoe size and y is her height in inches. Here we've got a chart with some data in it. We've got an equation for the line of best fit and a scatter plot with the line of best fit drawn on there. Y hat is the woman's estimated height. So it says, let's predict a woman's height when her shoe size is 6.5. So let x equal 6.5 and substitute the x value into the equation. So we are going to use the y hat equals 43.768 plus 2.772 times our x value of 6.5. And we get an estimated prediction that a woman whose shoe size is 6.5 will have a height of about 61.8 inches. Notice, and please be aware, that you can only make predictions that are in between your largest and smallest data points. So you can't make a prediction that isn't part of this line of best fit. Outliers. Outliers are points far from the line of best fit. The difference between the actual y and the estimated y for an outlier is large. Outliers need to be examined closely because in some cases they should be deleted from the set of data points. In other cases, they should not be deleted at all because they are the key to the population under study. You must carefully examine what causes a data point to be an outlier. In this course, you will learn one method for determining outliers. If you take higher level courses in linear regression, you'll learn other methods for determining outliers. So